Sometimes when we're dealing with units, they get a little bit complicated because we're measuring more than one thing and saying how they're related. And a perfect example of this is, say, density. Now, we remember that density is simply a ratio of mass to volume. It tells us how much matter, mass, is in a given amount of space, volume. Now, these have very different units because mass is going to be measured in grams and chances are volume is going to be measured in milliliters. Now, a milliliter is a special name for volume, and what it really is, if you took a 1 centimeter long line that has a length of 1 centimeter, we could go in 2 dimensions, and now we have an area. It's 1 centimeter by 1 centimeter. It's a 1 centimeter square, right? So this is 1 square centimeter. But then we want it to have volume, so we're going to have to go into 3 dimensions. So we go out this way, and now instead of having 1 centimeter square, we have 1 centimeter cubed. That's literally 1 centimeter times 1 centimeter times 1 centimeter. That 1 cubic centimeter is what we say 1 milliliter is. Those are the same thing. So when you have grams per milliliter, you also have grams per cubic centimeter. Those are the same unit. They describe the same amount of space. But when I start going with density, now I want to know how much stuff actually fits inside this box. How much matter can I cram in there? And it's different for different materials. But let's say we're dealing with aluminum. Aluminum has a density of about 2.7 grams per cubic centimeter. What if I want that in kilograms per cubic meter? And oftentimes I do, because usually we measure mass in kilograms because a gram is small, and we measure distances or volumes with meters because it's the base unit of length. So what I want to do is I want to figure out how I can get 2.7 grams per cubic centimeters to change into kilograms per cubic meter, right? Now, all that means I have to do is I have to change the grams to kilograms, and I have to change the cubic centimeters to cubic meters. Okay? I need conversion factors for that, or I need to remember how the metric system works. But remember, 1 kilogram is the same thing as 1,000 grams, and remember that 1 meter is the same thing as 100 centimeters. There's my 2 conversion factors. And now I'm going to write this out instead of as this slash. I'm going to use a horizontal bar, and I'm going to keep track of all my units. So I'm going to take 2.7 grams over 1 cubic centimeter. Now, I want to get grams to go away. So I'm going to multiply this by a conversion factor that has grams on the bottom, which means I'm going to divide both sides of this conversion factor by 1,000 grams. So 1,000 grams is the same thing as 1 kilogram. Okay? I did that because that gram cancels that gram, and it leaves me with kilograms, which is what I want. Now I've got to get rid of these cubic centimeters. Okay? I've got to be very, very careful with this. I have cubic centimeters, but my conversion factor is just for centimeters. If I want cubic centimeters, I need to cube this. Now what I do to one side, I have to do to the other. So I'm going to cube this, cube that. Well, 100 cubed is 1 million, 2, 3, 4, 5, 6 cubic centimeters is the same thing as 1 cubic meter. Don't make the mistake of just cubing the unit. You've got to cube the whole thing. So now I see that 1 cubic meter, which I want on the bottom, because I want my centimeters to change to meters, is the same thing as 1 million cubic centimeters. So that cubic centimeter cancels that cubic centimeter, and my grams are gone, so I'm left with the unit of kilograms per cubic meter, which is good. That's what I want, but I still have to do the rest of the math. I have 2.7 times 1 times 1 million over 1,000. Okay? And technically this is 1 times 1,000 times 1, so 1 times 1,000 times 1. But multiplying by 1 doesn't mean anything. So those 3 zeros I can cancel with those 3 zeros, and so what I end up with is 2.7 times 1,000, or 270 kilograms per cubic meter. So when you're doing a unit conversion where you have derived units, which is units made up of more than one unit, it works exactly the same way as doing a unit conversion with base units, except you've got to keep track of multiple units.